stop now. Net.
Okay, so as you know that, as these are the file or what we call as typically in icons required for various options like new model, open, network close. All those things are simple as your previous any software wherever you go. Like you are having these options like save, close as, save as. Okay, and one more is your import. Import in the sense you can import your sketch from any of a CAD model. Import your part in the sense part modeling. Whatever the part modeling you have developed in CATIA or UG, any AutoCAD or this thing. So you can import that, as well as assemblies. Assemblies in the sense the entire assembly you will be doing in your tree, in your CAD modeling. Like considering a CATIA, it will be having any actions you do on the screen, it will be taken into a tree. That assembly you will be doing, that assembly you can directly import it. And model in the sense your FE models. You do a preprocessor in any other softwares like preprocessor, ANSA, HyperMesh, any other ANSYS Workbench or Design Modeler, any of the preprocessor, you do a FE meshing there, that is your discretization, you import them directly to here. As export, the same thing. You can export whatever you do here, you can export it to various formats. Okay, for example, I'll just show you. One is model. You can see at the file filters, it shows as .cae. .cae is nothing but the extension of your Abaqus file. Whenever you save the file here, like for example, I take a save. So you can see this file will be saved as. One second, I'll take to a desktop itself. So Abaqus, sorry. Anything. So if I take this, so whenever I save the file, if I save the file here by the name your modal analysis, so your file will be saved as modal.cae. The extension will be the .cae. Whatever you do in ANSYS CAE, Abaqus CAE, you will be getting saved into this as .cae. This .cae cannot be used by other softwares. Only Abaqus can be used. Whereas the other extensions will be there. Whenever you do a model, okay, and then you want to export it. Export in the sense you will be having an option here. Go to model, part, import, or you do directly as export. Export as a part. So part is missing, so it will not show. It will show as .part or .igs or .stp. Typically any CAD software, what we want is like .stp or .igs. So for example, I'll show you one thing. In CATIA, if I do a CATIA modeling, okay, so directly that will be saved as .cat. That is a CAD part, CATIA part, okay. So for that, but we cannot directly take that CAD part here. So what we'll do is like, as a part, okay. So if I take this thing, sketch, I'll just consider this. Okay, so if I want to save this file, what it gives, it gives as CAD part. So when I save this, it will give a CATIA part, okay, but it will not be used. But for that, what we do, we have an options here. .igs, .stp are general, what we call extensions, which are used only the CAD geometries. It will not take any of your sketches. It will not take any of the material applied to the structure or made in a CAD model. Only your solid geometry will be taken. So for example, this CAD part 1. Okay, so you can see that this has only as a work or part .stp, part 1 stp. It doesn't have any software requirement. It has only .stp file. So now that stp file I can directly import here. You can see here it will be having various options like IGS, VDA, STP, CATIA. So these are particular softwares, Parasolid, ProE or .odb you require anything for that. But I require is .stp what I have taken, .step step file. Okay, so that is in this folder part. So just here you have the option again, you can import or create an individual parts. If it is an assembly, you require a combined one or a individual parts. So you can choose here. So when I take that, so you can see the one part, or this is not the one, sorry. Where it is save as, go to .stp. Okay, the part .stp is saved. Now I'll go back to the same. So I'll close this. I don't want to require. So import stp at Abaqus. So part 1. So if I import it, I can get that solid directly. There are no sketches. When you see here in the part, so features, only step geometry is required. When you build your CAD here itself, you will be getting the sketch here itself. I'll show that. So closing this. So part, right click here, you will be having option 3D, 2D, axisymmetric, all the options here. Which you want to create. You want to create a 3D solid model or 2D planar or axisymmetric model. Again here, you will be having type deformable, discretized rigid, analytical rigid and Eulerian. So where you use these all type, where you require deformable is nothing but your any part which is area of interest. In the sense, your water bottle you are modeling. Okay, this is your deformable body. When I throw this bottle to the floor becomes a rigid body, right? So the rigid body also need to be generated. For that, discretized rigid in the sense, it will be having a points what energy it is observing. That energy, if you want, you can use a discretized rigid. Only analytical rigid, it will behave like a rigid. You will not get any result on that. Only your bottle or your body will be getting the result. Eulerian is nothing but the body follows the Eulerian equations as you have studied in your M1, M2 I think, Eulerian equations to solve, or Newton's-Raphson's method, right? Those mathematical equations will be used to solve the problems. Okay, so that is what the method. So I'll be using a deformable here. And next again, what type of shape your body is. Like, is it solid? You require a solid, or it is a shell in the sense 2D elements. And wire is your special 1D elements. And points, your each what we call a space point. It's just a point representation. It will not be having anything. So what we'll do, again we have a type of options here. What type of options? Like you want to revolve the sketch, or you want to extrude it, or you want to sweep it. Three options, like revolve in the sense, extrude in the sense your model or geometry sketch will be having certain thickness over it, and revolve in the sense at particular axis your geometry will be made into revolvation. And sweep, again what layer of sweeping, you understood? So that methodology will be used. Similarly for shell, like planar, extrusion, revolvation or sweep. Planar in the sense to create a plane, just a plane, there will be no thickness over it. Okay, and extrusion, same thing. Next is wire in the sense any 1D element need to be created. So for that, only a line, thin line, wire in the sense a thin line need to be generated. So point or coordinates need to be given to a space point of that. So I will be using a solid here for your first modal analysis. So I will be using, according to your syllabus, it is a plate with a hole. As you already studied that at your graduation, that is your 4th semester FEM lab, 4th or 5th, with a plate with a hole, you give a temperature on one side and check the temperature on the other side for the conduction based, right? You have solved it. Same similarly, sorry, for the same similar, I'll be doing it with for the modal analysis to check that mode shapes. Okay, so I'll be taking this approximate size in the sense